Are these both perfect squares? Yeah. How does x squared break down? X times x, which is x squared, right? And what about 9? That's what? 3 squared. So it looks like difference of 2 squares to me, right? Yes or no? Yes. Bobby, will you say that louder, please? Are we subtracting? We're adding. So can we break this down? No, this is as far as we can go. This doesn't factor anymore. Now, when something is not factorable, we call it prime. Which means, prime means what? That it is as small as possible, right? So we would call this prime. It's as small as possible. We can't break it down anymore. So we are done. Let's try example. Okay, try example 5 on your own. 4x squared minus 4y squared. Do it now. Okay, so some people figured it out. The first thing that we're looking for in these problems is a GCF. And we can look at this one right away and know what the GCF is, right? What is it? 2. Ooh, it's not 2, it's 4. Look, both of these have a 4, right? We can read 4x squared as what? 2 times 2 times x times x. What about negative 4y squared? Negative 1 times 2 times 2 times y times y. So what would the GCF be? 2 and 2. What's 2 times 2? 4. So our GCF is 4. And when we pull that out, what's left over? X squared. Negative 1 times y times y. Negative y squared. So we pulled out the GCF first. Is this a difference of 2 squares on the inside? Yes, it is. We have x squared and y squared. So how would I break that up? Well, the first thing that we have to do is we bring down that 4. That's the GCF. We're always going to be multiplying the answer by 4. So 4 is on the outside, and then I set up my parentheses. 1 is plus, 1 is minus. So it's the same thing. This time we just had to pull out a GCF first.
Why do you have to plot the GCF?
So what goes in the first spot here? X and X. And what goes in the second spot? Good. Y and Y. So that would be my answer. Now, Bobby had a good question. She said, can't you do difference of 2 squares without pulling out the GCF? The answer is yes. In this case, you can. What would it come out to? 2x plus 2y times 2x minus 2y. Good. Okay. These two are the same. However, on your instructions, whenever we're factoring, you're going to be asked to factor completely. This is not factored completely. Can anybody see why? Not because you can still put it together.
Because of the 2's?
Exactly, because of the 2's. Look, x and y in each of these cases have a 2 still, correct? So what of this first parentheses would the GCF be that we could pull out? 2. So this would be 2 times x plus y. And does this one have a GCF also? Yeah, what is it? It's all 2. So we would multiply those 2 together, correct? X minus y. What's 2 times 2?
4.
So you would get the exact same answer. It's easier to pull out the GCF first. Okay, this is not factored completely. Not factored completely means we can't break it down anymore at all. We can still pull out a GCF from each of these parentheses, which is why this is not a complete answer. Okay? Okay, example 6. 3 squared minus 27. At first glance, does this even look like a difference of 2 squares?
No.
Is 3x squared a perfect square?
No.
No. Is 27 a perfect square?
No.
No. But looking at it right now, do they have a GCF?
Yes.
The answer is yes. Let's find it really quick. 3x squared. How does that break down?
3x.
3 times x times x. What about negative 27? How does that break down?
3 times 3 times 3 times 3.
Well, negative 1 times.
3 times 3.
Okay, negative 1 or negative 27 breaks down to negative 1 times 27. And how does 27 break down?
9.
3 and 9. And 9 breaks down to 3 and 3. So what would I get? Times 3 times 3 times 3. And that's it, right? What do they have in common? Just the 3. So let's factor out the 3. So we would get 3 times what? 3 times x squared. What's left? Negative 9. Negative 1 times 3 times 3. That gives me negative 9. Now, does this look like a difference of 2 squares?
Yes.
Yes, it does. X squared minus 9. How would that break up? We bring down the GCF.
X.
1 is plus, 1 is minus. What goes in the first spot?
X plus 9.
X and X. And what about the second spot? What goes there? Not 9. 9 is the same as 3 squared. So 3 and 3. So this is the same as 3 times x squared minus 3 squared, right? So 3 and 3 goes in each space.
That was really hard.
Okay? There are other problems. This is why you always check for a GCF first.
I'm gonna go cry my
And then we can factor it out.